All right, so we're on section 10.5, the last thing we're going to talk about in chapter 10.
10 point what?
10.5, Law of Cosines. So yesterday we said we were talking about all the different ways we've worked with trigonometry. With SOHCAHTOA, we were working with right triangles. That's what we did in our clicker review yesterday. We did all those problems where we found x in our right triangles. So those all had to do with right triangles. What we did on our opener today, using law of sines, that gives us a way to work with some triangles that don't have 90-degree angles. Law of cosines is just another way, depending on what parts of the triangle that we have, of working with triangles that don't have a 90-degree angle. So we're going to draw our triangle just like we did for law of sines. So we have some triangle. And we label the angles with capital letters and the sides opposite with small letters. So we're labeling our triangle just like we did for law of sines. And law of cosines says for any triangle ABC, with sides small a, small b, small c, we have three equations. A squared equals b squared plus c squared minus 2ac cosine a. So this is one of the equations that the law of cosines gives us. The other equations they're essentially the same. We're just rearranging the letters depending on which sides that we're working with. So they're all the same equation. They're all telling us the same thing. We can just write them with the letters in different places depending on which sides we work on. So b squared equals a squared plus c squared minus 2ac cosine b. And our third one, c squared, equals a squared plus b squared minus 2ab cosine c. So those are our three equations for the law of cosines.
Why is it for a squared and b squared? Why is it
Oh, I'm sorry. This should be BC. Thank you. Draw a better B. So these are equations for law of cosines. We get the equations, like I talked about with law of sines, by dividing this triangle into two right triangles and using the parts to write an equation. So for your quiz and for the final, you're going to need to have memorized SOHCAHTOA, law of sines, and you'll need to remember law of cosines. What I suggest on the law of cosines is just remembering one of these, because they're all the same thing, just depends on which side you put where. They're all telling you the same thing. Now, a couple of things about the way they look. I have a squared, the side a squared here, and I have angle a on the other side. The law of cosines always works that way. I have side a here, angle a on the other side. The other side also only has the other two sides. This is b and c, and b and c. Same thing with my other equations. Now let's look at this last equation. If I covered up this 2ab cosine c, what does that last equation look like? So I just covered that part up. That looks like the Pythagorean theorem. So somebody that has a calculator out, put 90 degrees, find the cosine of 90 degrees. Can someone tell me what the cosine of 90 degrees is? Cosine of 90 degrees is 0. If we have a 90-degree angle here, the law of cosines turns into the Pythagorean theorem. So the law of cosines is like an extension of the Pythagorean theorem. We could think of it as an extension of the Pythagorean theorem. If one of our angles is a 90-degree angle, law of cosines turns into the Pythagorean theorem. Questions on what we're looking at here. So remember that the side A goes on one side, the angle goes on the other, and the other two sides are on this side of the equation. All right, the way we use law of cosines, like we use the law of sines, we use it to solve triangles.
Not wait till pass.
And remember that solving triangles just means finding the missing parts. We use the law of cosines in two cases. The first one is when we have two sides and an angle between them. So this would be a side angle side triangle. We have two sides and an angle in between. And the second case that we use the law of cosines is when we have three sides. And that's when we have a side-side-side triangle. So these are the two kinds of triangles that we use the law of cosines on. The law of sines was when we had the other combinations of sides and angles. And another thing about the law of cosines is that if we solve a triangle, if we're looking for all the missing pieces, usually you would use the law of cosines once. After you use the law of cosines once, you have enough information then to use the law of sines. And the law of sines is a lot less complicated than this. So I'm just going to say we usually finish with law of sines. And we'll do when we do our examples, we'll talk about this again. So we use the law of cosines for a side angle side triangle and a side 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 triangle. The problems on our quiz and our test, the problems will tell you use law of sines, use law of cosines. So you won't have to figure out which one to use. When you work with law of sines and law of cosines again in Algebra 2 and in pre-calc, you will have to figure out when to use each one. So we're kind of just having kind of an introduction to using them in this class. All right, questions before we go on? All right, let's look at a couple of examples. All right, so here's our triangle. There's A, B, and C, and this angle is 50 degrees. C is 8 centimeters. B is 14 centimeters. And we want to find A. So here we have a side angle side triangle. So we use law of cosines. If we try to use the law of sines, we would find pretty quickly that we don't have enough information to use the law of sines in this triangle. We don't have a side and an angle and a side opposite. So there's no way for us to set up the law of sines with this triangle. Yes. Thank you. So we want to find this side A. We know angle A. So we're going to use the law of cosines. And I'm going to plug my parts of my triangle into the equation. We're looking for side A, so I'm just going to say a squared equals, and we know that we have angle A over here. It has to go on the other side of the equation. So we know that we're going to have a cosine of 50 over here. So the side A goes on this side. The cosine of the angle opposite goes on the other side. So I'm going to plug into my equation. B squared is 14 squared. C squared is 8 squared minus 2 times 14 times 8, 2 times B times C, times the cosine of 50 degrees. So I've just plugged all my numbers into the law of cosines. Now I'm going to write out a bunch of steps here just so we see everything that we're doing. 14 squared is 196. 8 squared is 64. Minus 2 times 14 times 8 is 224. Cosine 50 degrees. Now I want to point out here, this is where a lot of people make mistakes with the law of cosines. I cannot add 196 plus 64 and subtract the 224. The 224 is multiplying the cosine of 50 degrees. So I can't take that 224 away from the cosine of 50 degrees by subtracting. So these two have to stay together. I can't subtract this 224 from these numbers. So a lot of people get to here and they add these two together and subtract 224. This part has to stay together for now. So I'm going to write this as, I'm going to multiply this out now. 196 plus 64 minus 224 times the cosine of 50 is 0.6428. And I said yesterday when we were talking about the law of sines, when you calculate a cosine or a sine as part of your problem, make sure you keep at least 4 decimal places. Otherwise, you're going to throw your answer off. And now I'm going to add 196 plus 164 and multiply these two together and subtract. So 196 plus 64 is, what do I get there? 260 minus 224 times 0.4268. Can you calculate that? Times 0.6428. I get 134.9 or 143.987. And when I subtract those, I get 116. And I'm going to bring this down, a squared, a squared. I get 116.016. Here's the next place that a lot of people make mistakes with law of cosines. We get to here, and people want to say, oh, A is 116.016. I'm done. Remember, in the law of cosines, we get a squared. A squared is 116.016. A is the square root of this. And we get that A is about 10.8. And our units are in centimeters, so we get centimeters. So 2 places where people make mistakes. They forget to keep these two together, that these two are multiplying, and at the end we forget to take the square root. We have to make sure we're taking the square root at the end because we're solving for a squared. So now we know that a equals 10.8. If we wanted to, if the problem had asked us to find the other angles, the problem said asked us to find the other angles, now I have enough information to use the law of sines. I have this side, and I have this side, or this angle, and this side opposite. So I can set up my law of sines with sine of angle A over side A, and I could use side C and angle C, or side B and angle B, to find my other angles. So I would finish this problem with the law of sines if it had asked us to do more with this problem. And we'll do that in the next example. Everybody good with that example? All right, let's look at another one. This time we'll do a side-side-side example. So here's our triangle. And we'll label it, this time we're going to call this triangle P, Q, and R. And Q, side Q is 1.25. Side R is 3. And side P is 2.5. In this problem, we want to find all angles. So we have a side, side, side. So we're going to use law of cosines. And on this problem, I'm going to find angle R first. You won't have to worry about this now, whoops. But the reason I'm finding angle R first is side R is the longest side, so angle R is going to be the biggest angle. When we use the law of cosines, we want to find the biggest angle first. If we don't find the biggest angle first, we can run into some problems finding the other parts. And again, when you talk about the law of sines and law of cosines again in future math classes, you'll have to keep track of that. But when we use the law of cosines on side, 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 we want to find the biggest angle first. So I'm going to plug into my equation for law of cosines. I'm looking for angle R, and this is my side R. So I know that that side R is going to be on one side of the equation, and the cosine of my angle is going to be on the other side of the equation. So I'm going to write that this side squared equals, and I know that cosine of R is going to be over here at the end. And everything else over here is going to be my other two sides. So I'm going to say this is 1.25 squared plus 2.5 squared minus 1.25, or sorry, 2 times 1.25, I'm going to move this over, times 2.5 times the cosine of R. So I have my side that I have here, I have the angle on the other side, and the other two sides that are on either side of my angle are here in my equation. Now I'm going to start squaring things. I get 9 equals 1.25 squared is 1.5625. Notice I'm keeping 4 decimal places, so my answer is accurate. Plus 2.5 squared is 6.25. Minus When I multiply 2 times 1.25 times 2.5, I get 6.25 times the cosine of r. Now here's where we need to be careful. These two have to stay together. In these kinds of problems, a lot of people are going to say, oh, here I have 6.25 minus 6.25. That's 0. Those cancel out. We have to keep these two together.
Is A supposed to be 3 squared?
This is 9. Sorry, that's a 9.
Got it.
Okay. Hello. Now we can. I'm going to combine these. Thank you. What's that? Oh, those are strong magnets. I did.
It'll never come off.
Like, I have no idea. Yeah, hang on a second.